Welcome to Sweet Life Beat Life. We hope this video helps.
You start by validating essentials and then run one quick experiment so you know where lag begins. Check dataset shape and balance and profile hardware bottlenecks like GPU memory, CPU cores, disk I/O, and network latency. Once done, train a minimal model for a single epoch to capture throughput and per batch time. This gives a baseline metric to compare against later optimizations, and it informs which layer of the stack, data model, or infra, needs immediate attention. Next, focus on the middle steps where lag accumulates: data ingestion and model execution. You should convert datasets to cache-friendly formats and enable prefetching with parallel loaders to eliminate I/O stalls. Then apply mixed precision and gradient accumulation to increase effective batch size without OOM errors. Tune actual batch size to find peak throughput. Meanwhile, fuse operations and remove redundant layers. Schedule a short warm-up phase for the optimizer so GPU utilization ramps smoothly instead of stall. To finish, rerun your benchmarks and verify that each change improved throughput versus the baseline. You must profile again, observe where time is spent, and iterate. Apply one change at a time and record results so you can roll back regressions. If things still lag, a key troubleshooting step is to check for GPU idling, inspect host-to-device transfer rates, enable pinned memory, and ensure kernels are launched asynchronously. If transfer dominates, batching or co-locating preprocessing onto the GPU will usually resolve the final stalls.
Thanks for watching. Consider subscribing if we helped you.